So I asked you to use your prior knowledge about shapes or areas or whatnot to find the area of that rhombus, even though you do not know yet the formula for area of a rhombus. So what kind of things did you guys come up with for finding the area? Do what? What did you do? Oh, you don't know?
They would create a right triangle, which means 3 is the height and 5 is the base.
Right. So she noticed that if you look right here, it is just a right triangle. Okay? So if you were to draw it this way, we have 3 as the base and 5 as the height. Okay? So you can actually calculate the area of this triangle. Okay? And then you just have 4 of that same triangle. Okay, so there are 4 of those. So if you find the area of that single one, you can just multiply it by 4 to get the area of the total one. Okay, so I'm not going to do that because I'm going to give you the formula and then show you how easy it is to calculate instead. All right, so the formula for area of a rhombus or kite is area is equal to the diagonal 1 times diagonal 2 divided by 2. All right, so that's why this picture is over here to help you. Okay, so diagonal 2 and then the diagonal 1. Okay, so in this case up here, if this part of the diagonal is 3, that would make this other part of the diagonal 3 as well, right? So it would be 6. All right, similarly, this part of the diagonal is 5, which would make this bottom part 5 as well. So it would be 10. Take that divided by 2, so 60 divided by 2 would give us an area of about 30 units squared. Okay, so using your triangle method, did you get close to 30 units squared? Okay, awesome. All right, so you can either use triangles to find that, or you can just know the area of a rhombus or a kite. Okay. All right, what about for this second part? The area of this polygon. What'd you guys do with this one? Somebody raise their hand and tell me what they did for the area of this polygon. What can you do? Okay, where would the center of this polygon be? Yeah, it would be about 3.5, right? Because you know it's 7, so 7 divided by 2 would be about 3.5. Okay, so that would be like the center. So notice you can draw, once again, triangles around the entire figure. Okay, so once again, it's just a triangle game, and you can use those coordinates to be your lengths. Okay. So you know that this base right here is 2 since it goes from 0 to 2. And then you know that this is 3.5. So once again, you can use just some simple calculations to find the area. Okay? Or you can know the area of a regular polygon, which is simply just area equals 1/2 times the apothem times the perimeter. Okay, so we'll talk about what the apothem is, but just for right now, 1/2 times the apothem times the perimeter. All right, I think it is best explained over here. Okay, so the apothem is right here. Okay, so it is, notice it does not go all the way to the edge of this circle. Okay, so it does not go all the way to the edge of that circle. It is only that piece right there that makes this perpendicular. Okay, so it's kind of like the altitude, but a little different. Okay, you can kind of think of it as like an altitude. Okay, the other one is the radius. So notice the radius touches the outside of that circle. Okay, so that's kind of how you can tell the difference between the apothem and the radius. The radius will touch. The apothem will not.
And if there's not a circle there, the apothem goes to a side.
Yep.
The radius goes to a vertex.
Yep.
So if the circle's not there.
Yep.
I can circle that.
Okay. And then MPN, so angle right here, MPN, so this one, the angle formed by this, is called the central angle. Okay, you'll want to know that, the central angle. So if you think about this, it's kind of easy to calculate what that central angle would be, right? Because you know how many sides you have, and you know how many degrees are in a circle. So if you take the number of degrees divided by the number of sides you have, that would be your central angle. Okay? So that's why they drew the circle there, for you to make that connection. Okay? So once again, if you think about it, if you have a circle that's 360 degrees and it's cut up into pieces, this degree would just be the circle, so the 360, divided by the number of pieces that you can cut it up into. Okay? So for example, here we have a hexagon, yes? So if we take 360 divided by 6, that central angle right there would be 60. Okay? And that might help you sometimes find side lengths to find area. Okay? All right, does anybody have any questions on just the overall labeling or what we're kind of doing here? Okay. All right, let's move on to page 2. All right, so these are just going to be a bunch of examples. Okay, so I'm going to work through, let's see, I'll work through about 3 of them with you, okay? And then I'm going to turn you loose for the rest of the page. All right. All right, so for number 1, remember, what is the formula for a new area of a rhombus or a kite? Yep. So diagonal 1 times diagonal 2 all over 2. Okay, so in our case, diagonal 1 would be 14. Okay. And diagonal 2 would be 20. Okay, so 10 plus 10 would be 20. All right, so then 14 times 20 divided by 2 would give us an area of 140. All right, since we are working with area and we are kind of talking about area and lengths and whatnot, make sure you start writing your units. Okay, so this would be inches squared. Okay?
Is it the same for a rhombus and a kite?
Mm-hmm.
Nice.
Yeah. Look at that. You don't even have to use 2 formulas. Win-win. All right, does anybody have any questions on that? So just start making sure you're looking at units. Okay. All right, so find the measure of a central angle of the regular pentagon below. All right, and I had a good conversation when we talked about this word regular. Okay, so regular means what? Does anybody know what regular means? Yeah, Evan?
All angles are equal.
Good, so that is what allows us to divide that polygon into those angles, okay? The fact that it's regular, which just means from like B to C is the same length, from C to D. Okay, so that's just kind of what makes this pentagon regular. Okay?
I thought it was the opposite of Trinity.
You just got the look. All right. So, if we have a 360-degree circle, how many sides would we divide by? A pentagon has, good, 5 sides. All right, so the central angle, so the measure of angle BFA is equal to 360 divided by 5, which would just be 72 degrees. Okay, 72. All right, does anybody have any questions on that one? All right. And finally, let's look at number 5. I'm just going to do part A with you. Okay, so we have a regular pentagon. Don't laugh at my pentagon. I'm not very good at drawing them. Okay, so there is my pentagon-ish. It's not it doesn't look very regular, but that's fine. All right, so it has a radius of 4 inches. All right, so let's just say this is my center. Okay. Which one of those, the dotted line or the solid line, would my radius be? Good, solid. Why? Good, it goes to a vertex. Okay, so that's the important part. It goes to a vertex is how you know the radius. Okay, so I'm just going to draw this triangle kind of by itself instead of entwined. Okay, so this right here would be 4. Okay, and it has a side length of 3. So if this is our side length, that would still be our side length. Alright, so I'm going to take this triangle, kind of blow it up a little bit and turn it so that the right angle is here. So all I did was take this part of the triangle, so only half of it, and flip it, and there it is. Okay, so this side would still be 4, and instead of 3, it would be, 1.5. Good, 1.5, 1.5. Alright, so finally, in order to find A, or apothem, we would have 4 squared equals 1.5 squared plus A squared. Okay, so we're just using good old Pythagorean theorem. Alright, so that gives us 16 equals 2.25 plus A squared. Okay, so 16 minus 2.25, and then take the square root. What did you guys get A to be? What'd you get?
3.7.
Yep, about 3.7. Okay, so your apothem for that one would be 3.7. Apothem. Alright, so for the area of the pentagon, remember what's our area formula? Good, so half the apothem times the perimeter. So now that we found the apothem, you guys can use that formula to find the area. Alright, so go ahead and work on the rest of this sheet as a group, and then if you have questions, we'll come back and talk about. Alright, so on 6 part A, we have a regular hexagon, okay? It's real rough, I know, sorry. Alright, so if our center is here, we would have a triangle that looks kind of like this, yes? Alright, and it tells us that it has an apothem of 10. Okay? So I'm going to highlight right here. So I'm going to flip this angle over and redraw it so it is a right angle on the bottom. Okay? So my apothem here is 10. Alright, and I'm trying to find the length of one side. Alright, so down here is what I'm kind of concerned about, but that's only half of my one side, right? So whenever I get my answer, I'm just going to have to multiply by 2. Okay, so right now I'm a little confused because I only have one side length. Can anybody think of anything clever I can do to find the other side length? Kate?
Well, if you 360 divided by 6 would be 60, and so it would make that triangle a 30, 60, 90 triangle.
It would. Alright, so up here, so this whole central angle on this bigger triangle that I drew on this one, so that angle would be 60 degrees, yes? Alright, so if I cut that in half, my angle over here is 30 degrees, which makes a 30, 60, 90 triangle, okay? So you can either use 30, 60, 90 stuff, or if you rather use trig ratios, you can do that too. Okay, I'm of the trig ratio club, so I am going to start at 30 and think opposite over hypotenuse, opposite over adjacent. So I'd have tangent of 30 is equal to, for right now I'm just going to put s. I know that I'm going to have to multiply by 2, but just for the variable. And then over 10. Okay, so half of s is going to be 10 times the tangent of 30. Okay, so 10 times the tangent of 30 is equal to like 5.77. Okay, so if you take that answer times 2, that will give you your entire side length. Okay, so for the entire side length, I got 11.55, something like that. Okay, so 11.55. And that would be just units, since they don't give us one. Okay? So that is why those central angles come in handy sometimes. If you're only given one of the sides, you actually have more information than what you think. All right, so for the rest of this class period, go ahead and start working on your prep.